In this video, I'd like to do another example of adding vectors in component form to make sure you've mastered the procedure. So this is another case here where the question is on screen right now, so I would encourage you to pause and scratch out your own solution to this and see how close you are to getting it right. And I will proceed in the video to solve it here. So we have one vector with magnitude 10 meters per second, points 20 degrees east of south. Another has magnitude 15 meters per second and points east. What's the sum of these two vectors? Okay, let's call them A and B again. Okay, so the first thing I think I want to do here is draw this because there's too many words and numbers for me. My brain can't wrap my head around what that is supposed to look like. So the first thing I want to do is sketch it. So let's start with a coordinate system. Okay. So here's a coordinate system. The first vector has magnitude 10 meters per second and points 20 degrees east of south. That method of specifying directions like east of south we didn't talk about, but hopefully it's self-explanatory. That means 20 degrees, start with south and go 20 degrees east of that. So that would be a direction like this with 20 degrees here. And this guy has magnitude 10. Okay, then we'll do the geometrical vector addition while we're at it. Why not? Starting from the end of that vector, let's do vector B, which points east and has magnitude 15. So it should be 50% longer than vector A if I'm trying to draw this accurately. So I'll make it kind of long. And this guy has magnitude 15 meters per second. So straight away, just from the geometrical approach, I have a rough idea of what I'm expecting the answer to be. I'm expecting something that has a large positive x component and a fairly large negative y component. So that red vector is going to be my answer, which let's call it C again. So we'll call that guy C. And this guy's going to be A, and this guy's going to be B. Okay, so step one, we need to get all the components of all these vectors. So let's see, for vector A, I want to turn vector A into a triangle like that. The hypotenuse is 10. This angle here is 20. This is going to be AX on that side. This is going to be AY on that side. So this means we're going to have AX is positive 10 meters per second times, let's see, it's opposite of the 20-degree angle. So we'll have sine of 20. And that is going to be sine of 20 times 10, 3.42, positive. Okay, and then BX, I'm going to do all the X at once. BX is just simply plus 15 because there's no right triangle to draw for that one because it points in the plus X direction. Done. Okay, now let me flip over to the Y direction. Why don't I switch colors for the Y direction just to keep them as separated as possible in my mind. So AY, I can see it's negative because vector A points down and right. And I can see that it's adjacent to the 20-degree angle. So it should be 10 cosine of 20. So that's going to be cosine of 20 times 10 minus 9.40. And BY is going to be 0 because that vector points purely in the X direction. So now I can add them. So CX is going to be AX plus BX. So that's going to be 18.42. And in the Y direction, well, there's not much to do in the Y direction, but I'll write it down anyway. It's just going to be minus 9.4 plus 0. So minus 9.4. So there's the two components of C. As I expected, it has a large positive X component and a fairly large negative y component. If the question is satisfied with the components of C, you're done. If you want to know the magnitude and direction of C, you just need to put those back together. Let me just go ahead and do that for you, just for some practice. So I've got a vector here. Well, I've already drawn it up above, so I may as well recycle my same picture. Let's solve for this angle here. Call it theta. We haven't used theta yet in this problem. And I'm visualizing the triangle like this. So we have 18.42 up here, and we have 9.4 over here. So that means we would have tan theta equals opposite over adjacent. Let's try to save a little bit of space here and just jump to the answer. So theta is going to be inverse tangent of 9.4 over 18.42. Inverse tangent. And I got 27.0. And for the magnitude, I'm going to do Pythagorean theorem. So I'll have square root 18.42 square plus 9.4 square. By the way, you may have noticed there, I omitted the negative sign in front of 9.4. That's because it's going to get squared anyway. Technically, it's parentheses minus 9.4, whole thing squared. But of course, when you square negative 9.4, that's the same as squaring positive 9.4. So the negative sign actually doesn't matter in Pythagorean theorem. So 18.42 squared plus 9.4 squared equals square rooted. And I got 20.7. And that was units of meters per second. So there's my magnitude and direction of the answer. And the direction, by the way, is actually clockwise from plus x, based on my picture, you can see. Okay, so there's another example of adding vectors with the component representation and a little illustration of the geometrical representation as well.